If you're an amateur radio operator, you've probably played around with APRS, the Automatic Packet Reporting System. And if you're like me and you tend to have fun with software-defined radio, perhaps you've wondered, can you set up an iGate using an SDR to gate packets from RF to the APRS network? Well, the answer might surprise you, but you absolutely can. Today on Signals Everywhere, I'll be showing you how to create your very own iGate using a little bit of software along with an SDR such as the AirSpy or RTL SDR, so don't go anywhere. This project for me came somewhat out of necessity as I've been writing a lot of software that allows me to extend the capabilities of the APRS network and lets me do some interesting things such as set up mailboxes or track satellites via the APRS network. However, living in an apartment, I'm able to hear my local digipeater, but unfortunately, I am unable to be heard by the same digipeater. So I can receive messages, but I can't send them. How do we fix that? Well, we're going to set up an apartment iGate. To get started, we'll need a couple of applications. You'll need the first one you saw, APRSISCE 32, my personal favorite for APRS applications. You'll need Soundmodem, which is your data modem that allows you to communicate audio and data back and forth. And then you'll need something such as SDR++ or SDR Sharp for receive. And if you want to get into transmit, which we may cover in another video, you might want to look at SDR Angel, which will let you do both receive and transmit. Last but not least, you want to make sure you have a virtual audio cable. Links to all of this will be in the description below, as well as a link to my original video showing you how to install the drivers for an RTL SDR. And the first thing we're going to do is set up our APRS client. Now, when you download this, be sure to put it in a folder by itself because this will create a lot of files on first execution. So just to keep everything clean and tidy, put this in its own folder just so you don't have that problem. Put in our call here, K8SDR is my personal call. And now we also need a passcode because our backend connection to the APRS network with this software is actually APRSISCE, which is the Internet Services backend for the amateur radio APRS network. And since this is going to be an iGate, we are going to use an SSID of -10 as per the recommendation. And so we're going to go ahead and hit accept. And our APRS client is going to start up. So let's go ahead and I'm going to find a location here. And I'm not going to shove it right on top of my physical location, but we're going to ballpark this just for our video. We're going to say that we are roughly somewhere in this area just for the purposes of our video here. So you can see we are already receiving packets. Now these are packets being received on the APRSISCE network, not RF packets, but rather packets on the internet. To start gating packets from, say, a software-defined radio, we need to do some additional configuration. We're going to come up here to configure, and we need to come down to ports. We're going to create a new port, and this is going to be a KISS port. I tend to use Simply KISS, but either should work just fine. Now, before I actually create that port, we need to come back over to our applications, and we need to run Soundmodem. So this is what's going to actually take the audio from our RTL SDR and then convert it into data that the APRS client itself can understand and then inject into our network for us. So I'm going to go up to settings here in our Soundmodem and down to devices, and we get an input and output device. These are the devices that the software is going to use to send and receive data with. In this case, we're just going to receive data. So our input device, I'm going to go ahead and select as cable output. We can leave these all turned off. We don't need dual push to talk. Port can be turned off. We have KISS and AGWPE server ports. Let's actually go ahead and make this an AGW port. So we're going to call this Soundmodem AGW, and I'm going to create that port. And you're going to see it wants to know what kind of port that is. If we come back to Soundmodem, it's going to be 8000, and that's an AGWPE port. So that's TCP/IP. We're going to press OK to save those settings in our Soundmodem. And then back in our client, we're going to say it's TCP/IP. And then it wants to know the IP address or DNS name as well as the port. So this is localhost. We're going to put in 127.0.0.1. You could also type in localhost as one word. We also need the port, which is 8000 in our case. So 8000, we pressed OK. And we can set up our quiet time and what this is specifically meant to gate. So we can see this can do IS services to RF if we're transmitting. In this case, we are not. But we do want to gate RF to IS. So this will let the network know that our station is going to send these messages out, but it's not necessarily going to receive and then retransmit them. We also need to, of course, in that case, turn off the transmit enabled. And we can go ahead and leave the beacon on. We definitely want to have our messages go through. GPS data would also be nice. Bulletins, telemetry, and DX. Let's go ahead and pass all these message types here and just ensure we have transmit enable unchecked. We're going to hit accept. So this is now listening on that port. You can see the Soundmodem AGW port is right here. And so what we need to do now is actually put some data onto that port. So we're going to go back over to our software, and I'm going to start up SDR++, and I have an RTL SDR plugged into the computer currently. So with SDR++ set up, I'm going to go ahead and select our RTL SDR. And we can see it's already detected. And I'm just going to bring this down to, oh, I don't know, let's do 1.024 megahertz because we really don't need a whole lot of bandwidth here. We're just looking at a single narrowband channel. Make sure our bias is turned off. We don't want to be sending any power out. And everything else looks good. We're going to go ahead and actually, I'm going to show you the audio setup first. SDR++ doesn't care if you set your audio settings prior to starting your SDR application or your SDR device, but SDR Sharp unfortunately does require that you stop your SDR and set your audio first. So just to make sure that we get it out of the way, regardless of what you personally use, I'm going to show you right here. And let's see, here is our radio output. And let's see, that's going to go to the cable input. So that's the input of our virtual audio cable. And then if we go back to our sound modem, you may recall under devices, the input is the cable output of that virtual audio cable. So we should be good to go here. We're going to go ahead and hit play. Perfect. So 144.39, this is our APRS frequency. If we come over to sound modem, it is receiving on those channels. And then, of course, we have the APRS client application itself. So now we have everything essentially set up to do our iGate. All we have to do now is test it. If we come back over here, I can search APRSISCE for raw packets coming from this station. And you can see that so far the only station packets that have come from the station is our location information and the fact that we are in iGate, and it shows the settings for that particular iGate here. And that's the only messages we really have. Now I'm going to go ahead and turn on my Kenwood radio, and we're going to go ahead and transmit a packet locally, and we should be able to see very clearly with sound modem, the APRS software, and SDR++, how we are able to visualize all of this happening in real time. Test. Oh, there we go. And you can see that we are getting decoded messages as I send these out. And so let's see if we can verify that these messages were gated. If we look at our APRS client, you can see we have multiple messages coming in from KR0SIV-7. So if we take a look on APRS5, we can see under K8SDR-10, that's our APRS iGate, that we do see some location packets that it sent out. We see that it's an iGate and the message capabilities of that iGate. And you also see its usual beacon. But you're not seeing any of the messages that we've sent through to the network, and that's because we're only looking at the originating call sign here. So what we actually want to look at is the originating call sign of my personal portable Kenwood radio, which is KR0SIV-7. And if you look at the raw packet data here, you can see that I've got a few messages that have come through without acknowledgement. because my car is not on, so obviously they're not going to get out to corrosive-9, but they were indeed sent through K8 SDR-10 as our iGate. So it's fairly simple to set up once you have everything in order to gate all of these packets out from RF using a software-defined radio, and then get them out to the APRS network, keeping in mind that this will communicate with other devices that are on the RF side of the APRS network as well. So it's not going to hold you just to the internet section of that network. It's all completely bridged together. So it's a really nice way of setting up a iGate that will just easily, simply, and very inexpensively take your local APRS traffic, whether it's yours or just the traffic of those around you, and get them online so that they can be viewed by the greater amateur radio community. So if you all like this video, please give it a like, subscribe if you haven't, and let me know what you'd like to see in the future. I do want to touch on transmitting, but I have a few kinks to work out with that. It would be nice to have a full-blown digipeater that was just local to the apartment, super low power, for my own personal use. And that's something we can absolutely do. It's just a matter of a couple of kinks I have to work out. So I thank you all for watching, and I can't wait to see you all in the next one.